Where does the top go? The top goes to infinity. The bottom goes to, I cover the ones that are too small to mention. This one dictates at infinity, and this one dictates at infinity or negative infinity. These are too small. Don't even look. So negative infinity over negative infinity, so or infinity over infinity. So this is the second indeterminate case. And like before, please tell me the degree of the numerator. So please factor it out. And please tell me the degree of the denominator. Now, if we remember, if we look at this, what do we know from pre-calc? Same degree over same degree. What is the horizontal asymptote? Leading coefficient over the leading coefficient. Leading coefficient is, so the horizontal asymptote is 2. But this is what we know from pre-calc. But we didn't show you why. Now we're showing you why. Ready? So please give me 3 terms inside. Excellent. Very good. Denominator. Do we all agree with these steps? Please say no if you don't. Which one? Oh, yeah. Right here at the top, yes. Thank you. Thank you. Perfect. Do we all agree now? Okay, perfect. So where does this go? Where does this go? Remember, only when this happens, infinity or negative infinity, otherwise it's not going to go to 0. Only when x approaches infinity or negative infinity. If x approaches 5, then this will be 6 over 5. Okay, where does this go when x approaches infinity? Okay, where does this go? Where does this go? I'm simplifying x cubed with x cubed, and the answer must be
2.
4 divided by 2, which means y equals 2 horizontal asymptote. It's a rational function. I will not write at infinity or negative infinity only. In this case, at negative infinity only, because it's rational. Is this better? Do we feel better about this? Okay. Good. But this is what we did, but we did not show you in pre-calc why. We just threw a definition at you and said if it's the same degree over same degree, it's the leading coefficient over the leading coefficient. But we didn't tell you why. And now we tell you why. Is that clear? So that's why, also in pre-calc, we didn't tell you why when the degree of the denominator is bigger than the degree of the numerator, this will always go to 0. We never told you that. Now we did. We factor out the degree, and the limit of 1 over x is 0. We said when the degree of the denominator is bigger, then the horizontal asymptote is always y equals 0. But we didn't show you why. And now you know. Good. So let's choose anything else. We want to look at 20. Okay, very good. 20 is identical. We just have to factor out terms with fractional exponents. Or factors, I'm sorry. That's fine. Let's look at 20. So this is limit as x approaches infinity, t minus t, the square root of t, over 2t to 3 over 2 plus 3t and minus 5. So let me change everything and put everything in descending order so we can correctly identify everything. So t times the square root of t is, with minus in front, is t to 1 plus 1/2, which is 3/2, and plus t. And then 2t to 3/2 plus 3t and minus 5. Is this clear? T to the first power times t to 1/2. I copy the base and add the exponents. That's how I get t to 3/2. So t times the square root of t is the same with t to 3/2. Do we agree with that? Is that a yes? Okay. So now everything is in the correct order, so I can identify the type of limit this is. And when x approaches infinity, all these don't count. Don't cross them out like that. I'm going to come back and put them in. The numerator goes to negative infinity. The denominator goes to infinity. Doesn't matter. It's still infinity over infinity. I have no idea what to expect. As you see here, we had no idea what to expect. And it turned out that infinity over infinity turns out to be 2. We shouldn't even compare. There is no comparison. So this is basically saying it's an indeterminate case. You can find anything. Who knows? Nobody knows. Okay, the same thing here. I have no idea what we're going to encounter. I do have an idea, but I'm not going to tell you. So, like before, because it's the same degree over same degree, the answer must be negative 1/2. There is no other way. But let's go step by step. Okay, what is the degree at the top? You can say there is no degree. This is not a polynomial. I have to agree. But I will still have to factor out t to 3/2. And then I have negative 1 and plus. From 1, I subtract 3/2. So this becomes 1 minus 3/2, which is negative 1/2. So this is basically 1 over t to 1/2. So from power 1, I subtract what I pulled out, and I get this. The same thing in the denominator, t to 3/2, and I have 2 plus 3 over the same thing, t to 1/2, and minus 5, and that's easy, 3t to 3/2. And of course, this will approach what? This will approach what? And this will approach what? I simplify these two, and I get the answer. As expected. But now this time I have to show. In pre-calculus, we just said, okay, it's the same degree, done. But here I have to show why. So what is the answer then? Right. And I have to write that y equals negative 1/2 horizontal asymptote at infinity only. Because this is a square root of t cubed. I can't plug in negative infinity. This function doesn't even exist on the negative side. So this is carved in stone. It's not that the function doesn't have a horizontal asymptote at negative infinity. The function doesn't even exist in negative infinity. So did I write the horizontal asymptote here? Yes, I did. Okay. Okay, so now before we continue to something else, or we practice whatever you want me to do, I would like us to go through something like this, 26, 34, and maybe 24. So you choose. What do you want to continue with? Which one? 34? This one? Perfect. So let's take a look. Yes, I don't mean to torture you with all this, but there are so many different types of limits and so many different techniques. So in 34, it's limit as x approaches infinity from e to 3x minus e to negative 3x divided by e to 3x, but plus e to negative 3x. So first of all, I would like to identify where e to 3x is going when x approaches infinity. So e to 3x approaches whatever when x approaches infinity, and e to negative 3x will approach when x approaches infinity. Where is this going? Where is this going? Where is the first one going? Yes, of course. The first one is going to infinity. Where is the second one going? Yes, because I know that this is 1 over e to 3x, and when x approaches infinity, this approaches infinity. So therefore, this will go to 0. Perfect. Excellent. So now you'll tell me where the top is going and where the bottom is going, because we need to know the type of limit we are facing. Right, which is right over. Good. So this is the second indeterminate case that we are looking at. So what do you think we're going to do? Yes, what? Excellent. What? Excellent. Now carefully tell me what you have in parentheses, top and bottom. Yes? Yes, 1 minus e to negative 6x. Easy to check. E to 3x times 1 is e to 3x. Copy the base, add the exponents, and get negative 3x. The same thing here. Copy the base, add the exponents, get e to negative 3x. And these are gone. The numerator will go to and the denominator will go to. So then y equals 1, horizontal asymptote at infinity for sure. I have no idea what's happening at negative infinity. Maybe, maybe not. We haven't checked. Questions? Questions, please. Is this okay? Yes? Okay. So let's also look at 26. Limit as x approaches negative infinity from x plus the square root of x squared plus 2x. Like always, our starting point has to be from the inside. So which of these two is the most powerful term whenever we talk about infinity or negative infinity? Good. So where is x squared going when x approaches negative infinity? Infinity. Where is this whole thing approaching or going when x approaches negative infinity? Excellent. Where is this going when x approaches negative infinity? Excellent. So this is our number 3. Infinity minus infinity. No one has a clue what the result would be. Same thing with 0 over 0. Same thing with infinity over infinity. We have no clue. Okay, so I established that infinity minus infinity or negative infinity plus infinity, the same thing. But if I have the result in there like infinity plus infinity, what is the answer? Infinity. What if I have negative infinity minus infinity? What's the answer? True. But infinity minus infinity is unknown. To be exact, it's called indeterminate case. That's our third one. Okay, so what do you think? I'm going to copy the problem here. You don't have to copy it again. X plus the square root of x squared plus 2x. What is our starting point? What do you think would be appropriate here? What is the only thing that I can think of doing? My only option here. It's called say it again. Of course. That's my only hope. To multiply by 1. But a very special type of 1. Conjugate over conjugate. That's the one I need. Excellent. That's the one. I multiply by 1. Which means nothing. Not really. It means a lot. But I'm not changing the problem. Multiplying by 1, I do not change the problem. Okay. Can anyone give us the numerator? Parentheses. Or minus 2x. Either parentheses, right? Or minus 2x. And I will write the denominator. What happens at the top? Those two go away. The numerator is very nice and clean. It's negative 2x. And now we have to work hard on the denominator. Inside the square root, I'm going to copy x and minus outside. Inside the square root, please tell me the degree. Yes, please factor out inside the square root, not yet outside. Please factor out like we did a few minutes ago. Factor out x squared and tell me what you get in parentheses. Careful. Perfect. Careful with our next step. So remember, this is the square root of a times b. I can write the square root of a times the square root of b, where a is this and b is this. And I will do that. However, let's discuss the square root of x squared. What are the options? Two options. Option x for x greater or equal to 0 and option negative x for x less than 0. So please remember the square root of x squared is not x. It depends on x. It's the absolute value of x. If x is positive, then it will be x. But if x is negative, then it will not be x. It will be negative x. Okay. So then, knowing what happens here, tell me what I need to write. So I have limit as x approaches negative infinity. I have negative 2x at the top. I have x that I copy. Now what will this become? Since x approaches negative infinity, what do I replace the square root of x squared by? But there is a minus in front. So then what do I have to write? Exactly. Plus x, the square root of 1 plus 2 over x. What do you think I'm going to do next? Not in the numerator because there's nothing I can do there. But there is one more step in the denominator that I need to perform, which is, thank you very much, indeed, factor out x. And I have 1 plus the square root of 1 plus 2 over x. I'm happy. Here's what I'm happy about. That's why I'm happy. And now I can drop the limit operator. It's the final stage. Where does the numerator go? When x approaches negative infinity, the numerator goes to -2. There is nothing there. Where does this go when x approaches negative infinity? Good. So where does the denominator go then? 0, 1, 2. Good. It's 2. So then y equals -1. Horizontal asymptote. Definitely. For sure. Where? At? That's it. That's absolutely it. This was a very long problem. I need you to see something like this. I need you to see the third indeterminate case and how cumbersome it is, because it is. So let's summarize a little bit all these infinitely many steps here. Okay, first of all, I had to realize that this is infinity minus infinity. And you would have never guessed that the answer is -1, right? Would you have? No, of course not. Nobody would. So then the only chance we have is because of the square root. The only chance we have is to rationalize. Okay, so then after we rationalize, we realize the numerator is simplify -2x. And then I look at the denominator and I say, what do I do with this? So I start inside. I factor out x squared. I have a product now. I can use this rule that allows me to simplify the square root of a product as the product of square roots. And then I encounter a different situation. I have the square root of x squared, but the fact that x approaches negative infinity gives me the second option. So this approaches negative infinity. Luckily, there is a negative in front to change this into positive. Why luckily? Because otherwise this will go to 0, and then it will be a problem. Okay, so then I realize that these two terms have a common factor of x. I will simplify the top x with the bottom x, and then this goes to 2. The numerator goes to -2, and we're done. But there were a lot of steps in between. Any questions? Okay, I know this is, not, it's a lot to absorb. But let's also look at this one, 38. Because you will encounter something like this, and I think I have one on the handout. So 38. Any questions on the previous problem? It's a lot of work. It was a lot of work. Okay, 38. Limit as x approaches 0 from the right. So this is not a limit at infinity. But it may have something special. We'll see. Tangent inverse of natural log x. Okay. Where is my starting point? Exactly. Think in terms of log. Remember the graph of log. When x approaches 0 from the right, where does this go? Excellent. So now let me refresh your memory on tangent inverse. I think I did it, but let's do it again. Tangent inverse x or arc tangent x is the same thing. No, this is not 1 over tangent. This is just the inverse function of tangent. And this function has two horizontal asymptotes. one which is pi over 2 and the other one which is negative pi over 2. And here is the graph of arctangent. So knowing the graph and remembering the graph, please do so. Tangent inverse of negative infinity. Now we have the final answer. What is the final answer here? Negative pi over 2. As x approaches negative infinity, the function values get closer and closer to negative pi over 2. Which means can I conclude anything when x approaches 0 from the right that x approaches negative pi over 2? No. This is not a vertical asymptote and it's not a horizontal asymptote for this function. Any questions? Any questions? Any questions?
Can you summarize?
Yes.
Like the rationalization for the answer negative pi over 2 again, because.
So the graph of natural log, let me refresh our memory on natural log. So this is natural log. So first, 0 from the right. So 0 from the right, natural log approaches negative infinity. And now I'm looking at where is arctangent going when its argument, its x, goes to negative infinity. So it's when its x goes to negative infinity, the arctangent gets closer and closer to negative pi over 2. Better? Okay, perfect.
Can you do the, I was trying to write it down.
That's okay.
Part about the natural log. Can you explain the tie in there?
Yes. So when x approaches 0 from the right, function value goes to negative infinity. So now where is tangent inverse going when its argument gets closer to negative infinity? So as x approaches negative infinity, the function value gets closer and closer to negative pi over 2. Better? Okay. Any questions? Any questions? I have 14 minutes left. So I can, the last two sections of this chapter go back to what we studied before at the beginning of the chapter. I can just introduce that and then we'll stop. Or we can work on some other problems.
How about we work on some?
Okay, let's work on some more problems. Any preference? So let's go to the handout then. So on Wednesday, we're going to finish this chapter, and I would like to start reviewing. I did copy for you an old test, and I haven't checked, but I'm hoping that this is what they sent me from the copy center. Yes, that's what they did.
We're gonna finish chapter 2 Thursday.
Yes, yes, 2.7 and 2.8 go together. There are only two definitions in there.
So is it likely that we'll have our exam?
Our exam should be a week from today.
Okay, that's fine.
Yes. And we are going to do, no, a week from Wednesday, I'm sorry. I always use a session to review. So since I am not able to finish tonight, chapter 2, I'm going to finish it on Wednesday, and then we're going to review Wednesday and part of Monday. And the test will be a week from Wednesday. Okay, any questions? Is there anything you would like to select or? till you find something to select, I just want to refresh your memory on something. What was this? Which gives the rate of change between 2 points, of a function between 2 points that are very close to each other. Not the same, but very close to each other. Okay, but so this is the almost, not exactly. This is almost the slope of the tangent at P, right? How do I make this to be the tangent? Exact, not approximate, at P. As h approaches? Exactly. So at the end of chapter 2, we are basically connecting two concepts. One concept is a difference quotient, and the other concept is limit. So when we put those together, we're going to determine the exact slope of the tangent. Of course, this will be, however, a function called f prime of x. Okay? It's not going to be just one slope. It will give us the slope of the tangent line at any point where the function is, and I'll mention that next time. Okay? So we're just connecting these two. We're putting together two concepts of the entire chapter, and we finalize the chapter with this very, very important information that we're going to use moving forward. Okay, I'm ready for any problem that you would like to work on. Anything? So that will be 2.7 and 2.8 together. And we're going to work on problems. Oh, yeah, let's do this. I forgot. I almost forgot. Right here. So I can consider this chapter done without an example like that. So here we're given a bunch of stuff about a function, and we're asked to come up with an example. So there is, of course, more than one correct answer. So which one would you like to pick? We want to pick 7? 7 it is. So let's write down the information. And if you remember, again, I'm not forcing you to use a particular method, but I will definitely summarize the information, because without summarizing it, I will not know what to write and how to present the graph. So limit. So this is 7 on page 140. So limit of f of x as x approaches 2 from either side is negative infinity. Limit of f of x approaches infinity is infinity. Limit of f of x approaches negative infinity is 0. Limit of f of x as x approaches 0 from the right is infinity. Limit, I think this is the last one. Limit of f of x as x approaches 0 from the left is negative infinity. Yes, that was the last one. I have no idea what this all means, but we will decipher it together in a minute. Okay, I see 2. Okay, fine. So this is 0, negative infinity, infinity, there is 2. Limit from either side of 2 is negative infinity. Limit from either side of 2 is negative infinity. Tells me, that's my choice. You could have made that point exist. My choice is that the function is undefined there, and it's a vertical asymptote. Okay, limit of f of x as x approaches infinity is infinity. Okay, fine. Was it negative infinity? It doesn't matter really, but I just want to make sure that I didn't copy that incorrectly. Was it infinity or negative infinity? Infinity?
Correct.
Okay, perfect. Good. So that's clear. Then the limit of f of x as it approaches negative infinity is 0. Y equals 0 is a horizontal asymptote. 0. 0 from the right is infinity. 0 from the left is negative infinity. I choose x equals 0 to be a vertical asymptote as well. So here's my example of a function that fulfills the given conditions. And that's done. So at 0, this is an overkill. You don't have to do it again. Okay, this is an overkill. Okay. So the function is coming from 0 going to negative infinity on the left-hand side of the y-axis. Okay, fine. Then at 2, is another vertical asymptote. And the function is coming from positive infinity on the right-hand side of x equals 0, crossing somewhere, of course, and going to negative infinity on the left-hand side of 2. No problem. On this side, the function is coming from negative infinity and going to positive infinity. That's my graph. Any questions? Have we found anything from the handout or other problems that you would like to work on? Let's find one more. We have 4 minutes. Which one? So we just did a very similar problem today, this one. So please work on number 13, the second one. So we said number 5? Oh, I'm sorry.
Whatever one that's.
For the first one is a very important problem. Very, very important. I can't show it to you just yet. Algebraically. I mean, using calculus. I cannot. But what I can show you is the graph. And moving forward, we have to remember this one. We will prove it, I promise you. So sine x divided by x. And since we are determining the limit as x approaches 0 from either side, I only care about -1 to 1 and 1 to 3. That's all I need. So here comes the graph. Sorry. Of course, you can't see anything. I'll tell you why in a minute. Here comes the graph. Is this function defined at 0? Defined at 0? Not. It's not defined at 0, but who cares? What's the limit? The limit is, so yes, this is the x-axis, and this is 1, and this is 2 and 3. So from -1 to 3. So if I plug in 0, what do you think is going to happen? Of course. Of course. So moving forward, we have to remember this limit. Also, the limit of x over sine x is also 1 when x approaches 0 from either side.